In previous video, we introduced the basic constructor of the multilayer perceptron. We use two hidden layer, one output layer neural network as an example, as we showed here. We have input x0, xm. The first hidden layer, we have F neurons. In the second hidden layer, we have S neurons. We have final output. Layer. We have N neurons. We have output. So in this neural network, the most important factor is the synaptic weight, the W101 until the W3SO. All these are synaptic weight. So from previous chapter, we know that the synaptic weight play a critical role in the neural network. You can define your neural network is well trained if all the weight reach their optimal value. So here is, we have the critical question is how to train a multilayer perceptron. So that is the question we are going to answer in this chapter. So different from a single layer perceptron, in a single layer neural network or single layer perceptron, it's really straightforward. We can easily to find the adjustment for each training. But for the multilayer perceptron, it's that's not easy. It's complicated. Therefore, we can apply one very powerful approach to train the weight in the multilayer neural network. That one is the back propagation algorithm. That is what are we going to introduce in today's class. So in the back propagation algorithm, basically there are two phases. Phase one called the forward phase. So the signal goes from the left side to the right side, as we showed here. We call that propagate forward. So you know, at the left side is the input. So input multiply with their weight and then come into the neuron or the processing unit. And then we have the output, goes through the activation function, and then goes through the next layer. So this called the forward, propagate forward, the forward phase. So what they do here is pretty simple. Just use the input signal, multiply with their weight. The weight is current weight. It's not the optimal weight, just the current weight. The input multiply with their weight and then go through each neuron. We can do the summation here, and then go through the activation function and has the input work as the input to next layer until reach the output layer. So let's go the forward directions. So all they do is perform a function, just do the multiplication summation. This is the forward phase. Next phase is called the backward phase. The backward phase goes from the output back to input, as we showed here. The signal goes through the backward phase. So see one more time. Forward. This is the backward phase. At the current stage, the weight is W11N, W12N, W13N. Here is W21N, 22N, 23N. The superscript 2 means the second layer. Here means the first layer. This one means go to the first neuron. Okay, we simply use this one to indicate different layer and different neurons. And N means the current weight. And then after signal go backwards, the weight change to N plus 1. That is the weight be updated. So this is called the backward phase. So using the red arrow to indicate this. So what they really bring back, they bring back the error signal. So you know you have an input, you have the weight, and then you can get the output. Then we compare the output with the desired response. We get the error signal, and we use the error signal to adjust the weight. This phase called the backward phase. So they have two features. Feature one is they propagate the backward, so different from previous one. Previous ones go forward. The second feature is they do the feedback. The feedback means they bring back the error signal, use the error signal to adjust all the weight from each layer. So this is the whole picture about the backpropagation algorithm. Two phase, forward phase, backward phase. So, but one thing is same as what we learned from previous chapter is we use the error signal to adjust the weight at each layer. So we put everything together. We use the yellow color and the black color, red color. Yellow color means forward signal, and red one means backward signal. So here is you can have multiple training data. So if, for example, you have the input for the first set of training data, you do the input, and then you find the error. The error go back to adjust the weight. And then you have the second set of training data. You do the same thing. Forward, get the error. Use the error, go backward to adjust the weight. So this is the backpropagation algorithm. So now let's use this one as to show how can we apply the backpropagation algorithm to adjust the weight from different layer. That is the key. That is the important stuff we are going to learn in this chapter. But look at this neural network. It's really complicated. We have multiple inputs. We have multiple layers. So let's simplify this algorithm. Simplify this network first. So here we only have two input, x1 and x2. We have two layers. One is the hidden layer. We use the red color to indicate. Another layer is the output layer. So let's go through from the left side to the right side. We have two input, x1 and x2. The n means the n iterations. That's the n training data. Okay, x1 and x2. So the x1 go to the first. The x1 goes to the first neuron. We use this one with the red black dot with the white circle to indicate the neuron. And the weight from x1 to the first neuron is the W111N. Here we use the red color to indicate that that's for the hidden layer. The 1 means the first hidden layer. And the first one means that comes from the first input signal. This one means go to the first neuron. Similar for x2 is the weight from the x2 go to the first neuron is W121. 1 means hidden layer. 2 means the second input. This 1 means go to the first neuron. Similar for this one is W112. This one means the first hidden layer. This one means from the first input. 2 means go to the first neuron. Then for this first neuron, that equal to the x1 multiplies W11 plus x2 multiplies W121. We do the summation. That's equal to the V11. So this output goes through the first activation function, the V11. We use the red one, indicate that from the first hidden layer. And then we get the output. That one equal to the Y11. This one means hidden layer. This one means the output from the first neuron. Similar, the output from the second neuron equal to Y12. 1 means hidden layer, 2 means from the second neuron. And then we move to the output layer. We use the blue to indicate that for the output layer. So the Y11 and then multiply with the W211. 2 means the second, that's the output layer. This first, subscribed 1 means from the first input, and then this one means go to the first neuron in the output layer. Similar for the other weight. And then the V21 as the input to the activation function phi to 1. We get the output, the y to 1. And that one is the actual output. We compare with the desired response, D1. We get the error information, the E1. So similar for the lower part. Okay, this is the simplified multi-layer perceptron we are going to use to demonstrate how can we apply the back propagation to update our weight.